create a network, design the network. So we'll take the discussion forward. So basically yesterday we created a VNet number 1 that has 10.1.0.0/16. Right? So we created this virtual network here, which has got VNet 1 that is 10.1.0.0/16. And then we created a subnet number 1 that is 10.1.0.0/24. We also spoke regarding the private IP address. We also spoke regarding the public IP address, right? Now, there is a small difference between Azure and on-premise. In Azure, we follow a concept of 2 raised to the power n minus 5. In on-premise, we follow a concept of 2 raised to the power n minus 2, right? Means in Azure, in every subnet, 5 IPs will be reserved. You cannot allocate those IPs to your devices or to your machines. In on-premise, only 2 IPs will be reserved. You would not be able to allocate or assign those IPs to your devices or to your machines. For example, let's say I have a subnet here, 10.1.0.0/24. We already know that it will have 4 octets. Right? We also know how many IPs will be there. So it will have 2 raised to the power 32, that is the maximum we can have, out of which 24 bits are masked. That's equals to 2 raised to the power 8. That's equals to 256, out of which 5 IPs will be reserved. So how many we can allocate? 251. How the IPs will start? 10.1.0.0, 0.1, 0.2, 0.3, 0.4. It will keep on going like this till 0.255. That would be the last IP of this subnet, right? Same, if we have the same subnet in on-premise, we will have the same thing here. Only difference is here only 2 IPs will be reserved. So 254 can be assigned to the devices. Now, which 2 IPs are reserved here? First IP will be reserved for the network ID. This IP we cannot assign to a device. And last IP will be reserved here for broadcast, right? Similarly here in Azure, 5 IPs will be reserved. First IP will be reserved for network ID. 0.1 will be reserved for default gateway. .2 DNS, 3 DNS, and .255 broadcast, right? That is the reason you will see whenever we will be creating a first machine in the Azure subnet. Let's say if I create a VM number 1 here, VM number 1 will get an IP 10.1.0.4. If dynamic assignment is going on, it will get an IP 10.1.0.4, this IP in Azure. Why? Because the first 4 IPs, 0.0, 0.1, 0.2, 0.3, they are reserved. They cannot be allocated. The first IP that can be assigned is 0.4, right? Now, let's say, okay, let me draw it on the next page. Now, let's say this is our network, right? In this network, we have got 2 subnets. So let's say here we have got 1 subnet, here we have got another subnet. With both the subnets, we have got 2 machines each. Right? So here maybe we can have 2 machines. Here we can have 1 more network. And this we can have 1 subnet. Here also we can have a machine. So these 2 machines are getting IP from this subnet. These 2 machines are getting IP from this subnet. And this machine is getting IP from this subnet. So let's do a naming convention. So we are saying this is our VNet number 1, that is 10.1.0.0/16. And let's say it's in East US region. That's our VNet number 2. So we are saying it is 192.168 and it's in, let's say, a different region altogether. It's in West US region. Maybe here we can have subnet number 1, 10.1.0.0/24. Subnet number 2, 10.1.1.0/24. Say subnet number 5, 192.168.0.0/24. That is VM number 1, that is VM number 2, that is VM number 3, that's VM number 4, and that's VM number 5, right? So VM1 and VM2 are getting IP from subnet 1, 3 and 4 are getting IP from subnet 2, and VM5 is getting IP from subnet 5. Guys, can you please tell me, can VM1 and VM2, can they communicate with each other? Can 1 and 2 talk with each other? VM1 and VM2?
Yes.
Okay. And what about 1 and 2? Can they talk with VM3 and VM4?
No.
See, so there is a small change here. If it's an Azure network, if it's the on-premise network, if the network is on-premise, then VM1 and VM2 cannot talk with VM3 and VM4, right? Cannot talk with VM3 and VM4. But if it is the Azure network, 1 and 2 would be able to communicate with 3 and 4. Means in on-premise network, machines of two different subnet would not be able to communicate with each other. By default, the communication would not be on. But if it is the Azure network, VM1 and VM2 can talk to VM3 and VM4. Means in Azure network, all the machines can talk to each other as long as they are getting IP from the same network. They can be a part of same subnet, they can be a part of different subnet. By default, they would be able to communicate. So 1 and 2 can talk with 3 and 4. Right? Now, what about VM1, VM2, VM3, VM4? Can they communicate with VM5? It's a different network. It's in West US, it's in East US. Maybe they are 300, 400 miles away. No. So by default, they would not be able to talk. But what about if I give, let's say, a public IP to VM4 and a public IP to VM5? I am saying this VM4 has got, let's say, public IP1, and this VM5 has got a public IP2. Can 4 and 5 can talk? They still belong to two different networks. So far, these machines only had the private IP addresses. Let's say to VM4 we assigned a public IP address. To VM5 also we assigned a public IP address. They still belong to two different networks. Would they be able to communicate now?
If they have public IP, they should be.
Yes, they can connect. They can.
Because they are on internet.
Internet, yeah.
Right, absolutely. They are on internet. So public IPs are reachable everywhere on the internet. So 4 and 5 would be able to communicate. Now let's say an organization has two networks, maybe one in US, one in Canada. In US, they have got 500 machines. In Canada, they have got 700 machines. And they want their machines to communicate to each other. Let's say Accenture has a network in Noida, or in US, and Accenture has a second network in Canada, and they want, because the machines belong to the same organization, they want the machines to communicate. So we cannot assign so many public IPs. It's not like we cannot assign it, but it will be a huge cost. So whenever we are creating any architecture, cost plays an important role. Second, security also plays an important role. If we assign so many public IPs, it is too much vulnerable.
Highly vulnerable. Yes.
Right. So we cannot assign public IPs to each and every devices. How can we communicate between two networks? In Azure, there is something called as VNet peering, virtual network peering. So we can enable peering between VNet1 and VNet2. Right? When we enable peering between VNet1 and VNet2, VNet1 and VNet2 will start acting like a one big network. And now the machines of VNet1 can communicate with machines of VNet2 with the help of their private IP addresses. And this communication will happen over Microsoft Azure Backbone Network. So now VM1, VM2, VM3, VM4 can communicate with VM5 with the help of their private IP address. And this communication will happen over Microsoft Azure backbone network. We can achieve it with the help of VNet peering. Now this VNet peering is of two types. One is what we call as regional peering, and second one what we call as global peering. There are two types of peering. Very simple. Let's say VNet number 1 is in East US. VNet number 2 is also in East US. So basically both of them belong to the same region. Right? Second could be both of them belong to a different region. Let's say Canada East. Right? VNet number 2 is in a different region. So if both the networks are in the same region, and if we peer them up, it will be called as regional peering. If both the networks are in a different region, if we peer them up, it will be called as global peering. That's regional and that's global, right? So guys, can you tell me which one is this? What is the peering between VNet 1 and VNet 2? VNet 1 is in East US, VNet 2 is in West US. Is it regional?
Regional.
Is it regional or is it global?
No, this is global one.
This is global. East
Yeah.
US and West US, they are
West
two different
US.
regions, right?
In same region, if we'll do it, it's regional.
Yeah, in same region, if we do it, then it will be regional. But East US and West US, they are two different regions, so it will be considered as global peering. Okay, now let's move forward. Any questions before we move forward? Okay, let's say we have a network here. In this network, we have a subnet, right? And here we have a machine, and the machine does not have any public IP. So we are considering this machine so far does not have any public IP. Let's say this is internet, and that's our laptop. Let's do a naming convention. So I am saying this is VNet number 1. Let's say 10.1.0.0/16. It's in East US region. Subnet number 1, 0.0/24. That's VM number 1, 0.4. That's internet. And that's my laptop. So guys, tell me, if I want to take the RDP of this VM number 1 from my laptop, can I take it? Is it possible I can do the RDP of the machine?
Yes.
Okay. So if yes is the answer, please tell me how.
There should be some communication between the network, I mean, the laptop network to the Azure network. So maybe VPN or some kind of communications, right?
Absolutely. So there has to be some sort of a communication. But do we have any communication so far?
Right now, it's not. Yeah, it will not be able to RDP.
RDP.
Right now, it would not be able to see. Now, guys, how can we take the RDP? Right now, the RDP session is not possible, but how we can make it possible? What are the different methods by which we would be able to make it possible? See, one method is we can assign a public IP to a machine, right? But that's not a recommended practice because there will be so many machines. To every machine, we cannot do that. But yeah, that is one method. Second is we can have the point-to-site connectivity. In our machine, we can have the VPN client. We can connect with the help of VPN client. Third is we can do some sort of a netting. Maybe here we can have some sort of a firewall. With the help of firewall, we would be able to do some sort of a netting. Or we can connect with the help of gateway, right? So there are multiple options here. Traditionally, what we used to have is earlier organizations used to have something called as jump server. They also call that as jump box, right?
Yeah, what DMZ servers we use.
Right. So here, these jump servers used to have a public IP address. They will have a private IP too, but they also used to have a public IP address. So from the laptop via internet, we used to connect to the public IP of this jump server. And then from this jump server, we used to take the RDP of VM1, VM2, VM3. We will have so many machines. It's not like we just have a single machine. So we'll have VM1, VM2, VM3, VM50. From this jump server, because now we are inside the network, we would be able to connect to all the machines. Provided that the access is not denied, we would be able to connect to all the machines. Now, in this case, as a client, as a customer, we are responsible for managing this jump server. Who will be managing the high availability of the jump server? We, as a customer, we need to manage that. If jump server is not available, can we take the RDP? No. Who needs to manage the scalability of the jump server? Let's say this jump server has got 4 CPU and 16 GB RAM. If it can only entertain certain number of connections, if number of connections keep on increasing, jump server may not be available, right? Then probably we have to allocate more resources to a jump server. Maybe instead of 4 CPU, 16 GB RAM, we have to give it 8 CPU, 32 GB RAM, or 16 CPU, 128 GB RAM. So we need to manage the scalability of the jump server. In order to ensure that jump server stays up to date, we need to do the patching of the jump server. So all this part is taken care by us. Azure says, I am providing you a PaaS service. PaaS is platform as a service. Platform as a service means there will be an underlying infrastructure, and that underlying infrastructure will be managed by Microsoft. So they say I can provide you a service called as Bastion host. Right? It's a PaaS service. So who will be managing the high availability of the Bastion host? Microsoft. Who will be managing the patching of the Bastion host? Microsoft. Right? So there will be an underlying infrastructure that will be managed by Microsoft. What we can do with the help of Bastion host? With the help of Bastion host, we can take the RDP of those machines which do not have a public IP. We can create Bastion host. This Bastion host will have a public IP, and with the help of this, we can RDP those machines which do not have a public IP. In order to create Bastion host, first we need to create a dedicated subnet. We need to create a subnet first, dedicated subnet for the Bastion host. And the name of the subnet should be, Azure Bastion subnet. And then it can have an address range, let's say 10.1.1.0/24. Right? So what do we need to do here? Here, first we need to create a subnet that will be the Azure Bastion subnet. And after that, we would be able to create the Azure Bastion host. So Azure Bastion subnet, let's say 10.1.1.0/24. We have one more service called as Azure Firewall. You will get all these services when we will be creating a virtual network. You get the option to create a Bastion host, you get the option to create the Azure Firewall. We all know what we can do with the help of Azure Firewall. With the help of Azure Firewall, we can allow or we can deny the traffic. We can allow or we can deny the traffic based upon the firewall rules, right? So this Azure Firewall will have a public IP address. It will have a private IP as well, right? Again, Azure Firewall is also a PaaS service, a platform as a service. In order to create Azure Firewall, first we need to create a dedicated subnet. And the name of the subnet should be Azure Firewall subnet. The name of the subnet should be Azure Firewall subnet. And the address range is, maybe we can give it an address range 10.1.2.0/24. So first we need to create the firewall subnet, right? So first we need to create the firewall subnet. Let's say we create the firewall subnet here. That is with the name Azure Firewall subnet, range, let's say 10.1.2.0/24. And after that, we would be able to create the Azure Firewall here. Then whatever traffic is going inside the network, we can make it pass via Azure Firewall, right? Then while creating a virtual network, we also get an option to enable DDoS protection, we can say, right? DDoS stands for distributed denial of service. DDoS stands for distributed denial of service. Now, Azure public IPs are known to everyone. Even hacker can easily find out the public IP of Azure. And then there are certain websites from where we can even find out the ports which are open to our public IP, right? So let's say we would be able to find out the public IP of a machine. If we would be able to find out which ports are open on that public IP, we can Anyone, any hacker can easily try to hit the traffic on that particular IP on that given port, right? And they will keep on hitting the traffic continuously. They will try to bring the service down. They are not trying to hack the machine. They are just trying to bring the service down. So let's say you have an application server and a lot of requests are coming to that application server. So what will happen when legitimate requests will come? Application server would not be able to respond, right? Unwanted traffic basically bring the service down. So with the help of DDoS protection, we would be able to sanitize the unwanted traffic. We would be able to sanitize the unwanted traffic. This DDoS protection has two tiers. One is free tier and one is standard tier. Sorry, one is basic tier and one is standard tier. This basic tier is free of cost. We don't have to pay anything for the basic tier. It's free. And it is by default enabled. It is enabled at the entire Microsoft data center level. And even if in case you want to disable it, you cannot disable the same. Standard tier, we have to pay. We have to pay $30 per public IP per month. Right? So let's say in your infrastructure, you have 100 public IPs that you want to protect so that unwanted traffic can be sanitized. If you have 100 public IPs to protect, you have to pay $30 multiplied by 100. That's around $3,000 a month. Precisely, it is around $2,944 a month. So we have to pay this, right? If in case we want to use the DDoS protection. So these are a few things that you would be able to get while we will be creating a virtual network. Now let's come back to here. Now guys, tell me in this diagram, I am sitting on my laptop here. I have my laptop here, right? And as we discussed, as we can see in the diagram, VM1, VM2, VM3 does not have a public IP. Can I take the RDP of VM number 2 from my laptop? Can I take the RDP of VM number 2 from my laptop?
All right, no.
Right
Without
now,
that.
right now, no, absolutely. Now, let's say if I create the Azure Bastion subnet, let's say 10.1.2.0/24, and after that I create the Bastion host, can I take the RDP of VM number 2 now? Using the Bastion host, can I take the RDP of VM number 2 now?
No.
Answer is yes. What's the purpose of Bastion
No,
host?
no, but your laptop where is in your network is there is no communication, right, to the Azure network.
So that's
on
such
the
a
internet, right?
sorry. Yeah,
Laptop is on the internet, so it should be able to communicate.
yeah, it should be able to communicate.
Or if we have the Bastion subnet.
Yeah, basically after creating the Bastion subnet, you would be able to create a Bastion host. And that Bastion host will have a public IP. That is the same thing we try to discuss here. How can we take the RDP of those machines which do not have a public IP using
What
Bastion
about
host?
the ports? What about the ports? That means the public IP having all the ports open by default?
Public IP, so 3389 will be open, why all the ports will be open?
Oh,
See, RDP works on 3389, right?
yeah.
3389 port will be open
Hmm.
for the Bastion host.
Jitin, so when we try to
It means anybody can connect. If they knows the network details, they can log in from anywhere, anybody.
Okay. See, it means anyone can connect. Answer is no. Answer is no. Tell me, will everyone have the access to the Azure portal? Where is this network lying? Where is this machine lying? Where is this Azure Bastion host lying? Inside your Azure portal, right?
Okay.
And will everyone have access to Azure Bastion host or VM number 2? No, that access you can control with the help of RBAC. With the help of role-based access control, you first of all, you can control who can access this machine with the help of RBAC, right? If a user has no access to this machine, would that user be able to even see this machine? No.
still, I mean, the hacker can still connect to a network, not to a specific mission, but they can still connect to a network, right? To the Bastion network.
And how? Okay, so you are saying the hacker would be able to connect to
Suppose I am in my office, okay? In local, I have a laptop. So I basically RDP to the Bastion servers, okay? And from there I can access all the servers, right?
Okay, see, we cannot access the Bastion host by the
Okay.
time we are not getting the access to the Azure portal. So let's say I have a Bastion host, and if I even give you the public IP of the Bastion host, still you would not be able to connect. In order to use Bastion host, we have to log into the Azure portal. So if you try to do it from a different tool, from PowerShell or CLI, you would not be able to access it. You have to go to a portal, from there only you would be able to access it. So let's say if hacker is able to get the public IP of the Bastion host, still it would not be able to connect to the machines, because now it needs the credentials as well in order to log into the portal. And how we would be able to secure the credentials? We discussed we can use MFA, identity protection, conditional access, PIM, we can use so many features, right?
So it means first we have to log into the portal, then from the laptop directly do RDP. Suppose I log into Azure portal, okay. After that, I go to the MSTSC, then I type the one of the
No,
IP address of the VM, then I can access. No.
Not via MSTSC. Let me show you. I think let me just avoid this confusion. Let me show you. See, let me create one network, and that will avoid this confusion.
But Jitan, I've seen people directly access the server, right? Like no need to log in RDP Azure. You can do MSTSC and you can type the Azure IP and it's accessing the servers.
Yeah, absolutely. If the machine has a public IP, absolutely you can do it. What you are saying is correct. But if a machine has a public IP, right? Or if you know, let's say if you have a firewall, on a firewall you are doing a natting, then also you can do it with the help of MSTSC. I can do that as well, but not in case of Bastion.
Okay.
But not in case of Bastion. Let me show you that. So let's say if I click on create here, I am creating one network. Let's say I'm creating a network in RG1 with the name VNet number 1 East US. IP address, let's say I'm choosing a range 10.1, choosing a subnet here. Subnet number 1 10.1.0.0/24, right? Now when I click on next, that is security, it gives me an option to create a Bastion host, DDoS protection, and firewall. Let's say we are enabling this Bastion host. What is the name? I give it a name, Bastion host. What is the address space? Let's say I give it an address space 10.1.1.0/24, and this will have a public IP. So I give it a name, Bastion public IP. That's a name to the public IP. It will get a public IP now. And now I'm saying review and create. And now I'm saying review and create. So it will be deployed maybe in a moment. Now we'll deploy one machine, one virtual machine, which will get IP from this virtual network. So I'll say we'll try to deploy a virtual machine. So in the same resource group with the name VM number 1 in the same region where the network is, and let's say we are creating a Windows server, maybe Windows Server 2016, 4 CPU, 16 GB RAM, giving it a username as my name, giving it a password. Now, see, for better security, what we can do, we are not leaving any public inbound ports open. I'm saying no public inbound port should be open for better security, right? And then I will go to networking. First of all, in networking, I will try to ensure this machine is getting IP from VNet number 1, getting IP from subnet number 1, and this machine is also getting a public IP. Here it is getting a public IP. I don't want to give it a public IP for better security. I'll say none. Public IP should be none. I'll go to management and I will say boot diagnostics off. So I'm creating a machine. Machine has no public IP, has no public ports open, and I am creating this machine. It's getting IP from VNet 1 from subnet 1. So it will be deployed in a moment here.
It's saying 13,000 INR is applied for this VM.
13 rupees, 13.827, not 13,000 per hour. That's a cost, right? That's a cost like 13 rupees and 80 some paisa per hour. Oh, let's wait for a moment. Okay. So I'll show you once it will be created. Let's discuss it in the meantime. So
Okay.
please tell me, guys, can we take the RDP of this VM2? The VM2 has no public IP, or this VM1 we are creating. The VM1 has no public IP. Can we take the RDP using Bastion host? Answer is yes, we can take it. Right. Now, next question is, from this laptop using this Bastion, can I take the RDP of VM number 5? Now, VM number 5 belongs to a different network. We have created the Bastion host for VNet number 1. VM5 belongs to VNet number 2. For VNet number 2, we have not created the Bastion host. So using the Bastion host of VNet number 1, can I RDP VM number 5? Is that possible?
Yes, because peering is enabled.
Answer is yes, because peering is enabled. It is possible. So if peering is there, you can RDP the VM number 5 as well. But if peering is not there, then the answer is no, right? Okay. Now, let's see here. I think the machine is created. See, now if I go to this machine, the VM is now deployed. If I go to the machine has no public IP. So directly I cannot do the RDP, or directly I cannot go to MSTSC and I cannot type any IP, right? If we want to connect using Bastion, here there is an option called as connect. In this connect, we have three options. One is RDP. So if this machine would have got the public IP, I would have just clicked on this RDP. I would have downloaded the RDP file and I would have taken the RDP of this machine. But right now it will not work because the machine has no public IP. If it would be a Linux machine, we would have used SSH. Now here you get the option to use Bastion. Here you get the option to use Bastion. Right. So I think Bastion host is about to be deployed. It's not deployed yet. But it is still being deployed. See, if we want, we can even find out the public IP of the Bastion host. Let's say this is the public IP of the Bastion. So we can see here public IP of the Bastion. Right here, we would be able to say it says Bastion public IP. So here we can see the Bastion public IP. That's a public IP of the Bastion. So let's say, guys, I give this public IP to all of you. Right, I'm sharing this IP in the chat window. Can you try to connect to my machine?
We should not be, because we are not logged into portal.
Right. See, even if I go here, if I type MSTSC, right? Even if I type this public IP, where this public IP will take me? Nowhere. We have not created any NAT rule. There can be 100 machines inside my network. Which RDP this public IP will take? Right. So what we can do, if we want to take the public RDP, we have to go to this machine. We need to click on that machine. Right. We need to click on this connect here, and then we need to click on this Bastion. Now we are trying to use Bastion for VM number 1, right? So then here it will give us the option to enter the credentials. Once we enter the credentials here, we would be able to RDP this machine, right? So first of all, what do you need? In, let's say a person is able to get the IP of the Bastion host, the person needs to log into the Azure portal. He needs the Azure credentials. After the Azure credentials, he also need to have the RBAC access on this VM number 1. And then finally would be able to RDP the machine, right? Let's say here I just need to enter my username and password, and with the help of a browser over a secure protocol over HTTPS, we would be able to RDP this machine, right? Over a secure protocol, we would be able to RDP this machine. Any questions, any query, guys, before we jump forward? See, just like we done the VNet peering, there is something called as VNet-to-VNet connection. We have something called as VNet-to-VNet connection. Is the peering only method of connecting two networks? No. We have something called as VNet-to-VNet connection as well. So diagram more or less is same with some changes, absolutely, right? So let's say this is my VNet number 1, that is 10.1.0.0/16. And let's say it's in East US. That's a VNet number 2. Let's say 192.168.0.0, and let's say it's in West US. That's subnet number 1, 10.1.0.0/24. That's subnet number 2, 192.168.0.0/24. That's VM number 1. That would be 10.1.0.4. That's VM number 2. That is 192.168.0.4, right? In case of peering, we were peering VNet number 1 with VNet number 2. In case of VNet to VNet connection, we need to create the virtual network gateway. So here for VNet number 1, we will create a virtual network gateway. For VNet number 2, we will create a virtual network gateway. Right? In which region I should create the virtual network gateway, guys? In which region I need to create this virtual network gateway?
East
Both.
US.
East US. Virtual network gateway 1 should be in East US, and virtual network gateway 2 should be in West US, right? And these virtual network gateways have got the public IP. We can say public IP 1. So virtual network gateways will have a public IP. This will have a public IP too. Before we create the virtual network gateways, we need to create something called as gateway subnet. Without creating a gateway subnet, we would not be able to create a virtual network gateway. So we need to create something called as gateway subnet. Right? Maybe let's say 10.1.1.0/24. And here also we need to create a gateway subnet. So here it would be 192.168.1.0/24. After creating the gateway subnet only, you would be able to create a virtual network gateway, which will have a public IP. When we will be creating a virtual network gateway is of two types. One is VPN type and one is express route. Right? The one that we are creating in this diagram is VPN type, virtual private network gateway type. Right? The one that we are creating in this diagram is VPN type. It is of VPN type. And this VPN type has further two categories. One is route based and one is policy based. Right? Or you can. So this policy based uses policies, IPsec policies in order to route the traffic. And this route based uses routes in order to route the traffic. So if I have to say in layman terms, this policy base is using static routing and the policy base is using dynamic routing. So 99.9% of the times you will find out you will be using route based. 99.9% of the time you will find out you'll be using route based, right? Then there is something called as SKU. SKU stands for stock keeping unit. See, what does it mean? Let's say, guys, we have to purchase an Apple phone. I go out to a shopkeeper and shopkeeper says, hey, which Apple phone you want? I say I'm looking for Apple 12. Then shopkeeper may ask us or may ask me which SKU of Apple 12 you're looking for. 32-bit, 64-bit, sorry, 32 GB, 64 GB, 128 GB, right? So basically we have different SKUs. With different SKUs, there is a different price. There is a different configuration. There is a different capacity. There is a different capability. Similarly, when we are creating the virtual network gateway, it can be VPN GW1. With this, we get 30 tunnels, 250 connections, and 650 Mbps of throughput speed. Right? Let's say if we need more connections and a better speed, I can go with VPN GW2, 30 tunnels, 500 connections, and 1 Gbps of throughput speed. VPN GW3, 30 tunnels, 1000 connections, and 1.25 Gbps of throughput speed, and so on, and so on. So what maximum we can get? Maximum we can have 30 tunnels, 10,000 connections, and 10 Gbps of throughput speed, right? But when we get more connections, better speed, we also have to pay more. Once all this will be done, then what do we need to do? In case of peering, we were peering VNet 1 with VNet 2. In case of VNet to VNet connection, we need to connect virtual network gateway 1. We need to create two connections. One connection from virtual network gateway 1 to virtual network gateway 2. Second connection from virtual network gateway 2 to virtual network gateway 1. We need to create two connections. When we create these two connections, it basically creates a tunnel. And this tunnel is made over the public internet. And we call this tunnel as IPsec IKE VNet to VNet tunnel. We call this tunnel as IPsec IKE VNet to VNet tunnel, right? IPsec IKE stands for Internet Protocol Security and IKE stands for Internet Key Exchange. See, what does it mean? Now, VM number 1 can communicate to VM number 2 with a private IP address. These two networks are now connected. When VM number 1 will communicate to VM number 2 with the private IP address, the packet will flow via the tunnel. And this tunnel is made over the public internet. So basically, packet is flowing via the public internet via this tunnel. And since the packet is flowing via the public internet, we would like to encrypt the packet. We want to have a security. So this IPsec IKE is nothing but a protocol that will be used for the packet security. So IPsec stands for Internet Protocol Security and IKE stands for Internet Key Exchange. It will basically encrypt the packet while it is sending the packet via this tunnel. Right? Any questions, any queries, anything, guys? Okay. So guys, please remember, peering is peering. I'm talking about peering. Peering is non-transitive in nature. When I say non-transitive in nature means if VNet number 1 is peered with VNet number 2, VNet number 2 is peered with VNet number 3, it does not mean that VNet number 1 is peered with VNet number 3. A is peered with B, B is peered with C. Doesn't mean A is peered with C. It is non-transitive in nature. Sometimes people ask when to use peering, when to use VNet to VNet connection. See, peering is fast, easy to set up, right? Less costly. Then why should I use VNet to VNet? In case of peering, the packet is traveling via Microsoft Azure backbone network. The packet is not traveling in the encrypted manner. It travels via Azure backbone network, but it does not travel in the encrypted manner. If there is an organization and the organization has a compliance that whenever packet is leaving the boundary of a virtual network, the packet should leave in the encrypted manner, then we can go with VNet to VNet connection. If you have a requirement that you have to connect your Azure network with the on-premise network, you cannot achieve that with the help of peering. Then also we will be needing this virtual network gateway, this gateway subnet. If you have a requirement that you want to have a point-to-site connectivity, means maybe in your employees' machines, there can be a VPN client. And with the help of the VPN client, they can connect to the organization network. Then also we need to use this virtual network gateway and this gateway subnet, right? So these are few things where this would be helpful. These are few things where this would be helpful. Any questions, any queries, anything, guys? That's all for my info today. If you have any questions, any queries, please feel free to ask.
Actually, I'm unable to understand that when we need to use a VNet or when we use the pairing. Please, can you
Yeah.
elaborate a bit?
See, let's say you have 5 networks in Azure. You want to connect those networks. You can simply use peering, right? All the networks are in Azure. You can connect them with the help of peering. But let's say your organization says you need to connect 2 networks, but you also need to ensure that whenever a packet is leaving one network and going towards another network, the packet should leave in the encrypted manner. You cannot achieve that with the help of peering. In peering, packet is going via Azure backbone network, but it is not traveling in the encrypted manner. So you will go with VNet.
Unsafe. It's very unsafe, right?
Sorry.
It's unsafe means it's not secure.
See, it's traveling via backbone network, but it's not traveling in the encrypted manner. So yeah, you can say that here it is going in the encrypted manner, right?
Okay.
Second is, let's say your organization says you have to connect your Azure network with the on-premise network. You cannot connect that with the help of peering. Then also we need to create this virtual network gateway, and then also we need to have this gateway subnet, which was not required in case of peering. Your organization says you have to give a point-to-site connectivity to all the employees. Let's say all the employees are working from home. If in case the employee has to connect to the organization network, in the employee's machine, we can deploy the VPN client and they can connect to the VPN client. See, where does a VPN client connect? So VPN client will be connecting to this virtual network gateway. So again, this would be helpful. So in those scenarios, we will be using VNet-to-VNet. Hope it gives you a fair clarity.
Okay. VNet, it is termed as VNet to VNet, right? Okay.
Right.